Remember back in 2015 when the world was taken aback by the first close-up images of Pluto? This was thanks to the New Horizons probe developed by NASA, which, after a nearly decade-long journey, flew by the famous dwarf planet, and the pictures it sent back astonished us all. In this video, we will uncover exactly what New Horizons found and explain why we might not see anything like this ever again. You are watching Turbo Mind. For years, the best images we had of Pluto were taken by the Hubble Space Telescope and were only a few pixels across with practically no surface details revealed. In order to resolve this gap in our knowledge of the solar system, scientists proposed sending a probe as part of NASA's New Frontiers program. This was subsequently selected, and New Horizons was born. The New Horizons spacecraft was launched in 2006 atop an Atlas V rocket, kitted out with 5 solid rocket boosters and an additional third stage, the most capable rocket available back then, all to provide the maximum delta-V possible. Leaving the Earth's gravity at the highest achievable velocity was essential in cutting down the travel time of this spacecraft, speeding past the Moon's orbit in 1/10 of the time it took the Apollo missions to get there. During its 9-year journey to Pluto, New Horizons undertook a gravity assist at Jupiter. This presented an opportunity for NASA engineers and scientists to test its cameras and sensors on the gas giant to ensure everything was functioning as expected. When this was completed, the probe was commanded to enter hibernation mode to preserve all of its onboard equipment. Other than for brief systems checkups, it remained in this configuration until December 6, 2014, around a month before beginning the approach phase of its journey in January of 2015. Over the next few months, we saw Pluto grow in the field of view, revealing more detail with each passing day. On July 14, 2015, the New Horizons spacecraft passed within 12,500 kilometers of Pluto's surface at a speed of over 84,000 kilometers per hour. Throughout the flyby, the probe kept its instruments trained on its target, meaning aligning the antennas to transmit data back home had to wait. When the data dump did finally begin, it was a painfully slow process, with a rate of approximately 1 kilobit per second per transmitter, not to mention a latency of more than 4 hours one way. Once the data began to arrive, scientists were able to piece together exactly what New Horizons saw. The secrets of Pluto were finally revealed. One of the most astonishing aspects of the dwarf planet was the sheer variety of terrain seen across its surface. They saw glaciers, ice plains, mountains and valleys, not to mention large patches of different colors, white, red, and beige. One such patch is the prominent pale heart shape seen in the northern hemisphere, which has been given the name Sputnik Planitia. This large ice-covered basin is approximately 1,500 kilometers wide and consists mostly of nitrogen ice, which at these temperatures and conditions, approximately -229 degrees Celsius, is much less rigid than water ice, allowing it to flow over long time frames as glaciers. It has since been hypothesized that Sputnik Planitia was formed after a large impact created the basin shortly after Pluto's formation, which was slowly filled with these volatile ices, although this remains a theory and other ideas have been proposed. New Horizons also revealed the presence of an atmosphere on Pluto. Although it's approximately 100,000 times less dense than the atmosphere at sea level on Earth, it was still more prominent than many people expected, consisting mostly of nitrogen with traces of methane and carbon monoxide. These gases are all vaporized from different types of ice found on the surface. Images captured during this mission also reveal a visible layered structure to the atmosphere, with more than 20 distinct layers of haze shown in certain images. We have also identified several cryovolcanoes protruding from the surface. These spew out large volumes of ice slush, consistently reshaping the surface around these peaks. Some people have suggested that the presence of these volcanoes may point to there being some internal heat source within Pluto itself. In 2020, a paper was published using data from this mission, hypothesizing the existence of an ocean of liquid water hidden under the surface of Pluto. This paper suggests that Pluto had a so-called hot start, with the process of its formation providing an initial source of heat required for a liquid water ocean to be formed and maintained. It is claimed that this may be the case for many of the larger objects found in the Kuiper Belt. The New Horizons mission also helped to uncover details about Pluto's largest moon, Charon. With half the diameter of Pluto, Charon is an uncommonly large moon when compared to its parent body. Its gravitational influence is such that the barycenter of the Pluto system actually falls outside Pluto itself, meaning they both orbit a point between the two objects. Pluto and Charon are tidally locked to each other, meaning that the same side of each body is always facing the other. With an average distance of less than 20,000 kilometers, it is common for material being spewed out of the cryovolcanoes on Pluto to escape its gravity entirely and make its way to Charon. As a result of this, we see a dark brown patch on the moon where this ejecta has landed. The orbit of Pluto around the Sun is substantially different from those of the major planets. It is both elliptical and tilted, spending most of its time outside the orbit of Neptune, but dipping inside briefly on this trajectory. This regularly varying distance from the Sun introduces some interesting seasonal phenomena on Pluto, occurring throughout the 248-year cycle. For example, the atmosphere will expand and grow outwards as it moves closer to the Sun due to it receiving more heat from the star, then contract as it moves further away. This temperature change has also been predicted to alter the movement of the nitrogen ice glaciers moving and growing at varying paces throughout the year. The vast majority of the data captured by the New Horizons probe about Pluto was obtained within a very short window of time during the flyby. So you may be asking why it didn't stop to orbit the dwarf planet. That way it could be taking measurements over a much longer time span, observing changes and processes over months or years. The answer is simple: physics. In order to enter into orbit, a spacecraft would need to reduce its velocity enough to allow Pluto's gravity to capture it. New Horizons was traveling at more than 84,000 kilometers per hour, and with no way near enough maneuvering fuel left over to slow down. In fact, bringing enough fuel to slow down a probe like this is simply not viable, especially without lengthening the journey by decades or even centuries. The New Horizon mission was a spectacular success, shedding light on a part of our solar system that has been a mystery to us since its discovery almost a century ago. So why are we unlikely to return and build upon this great achievement? The answer is simple: there are so many other places to go. Another probe to Pluto would just not represent a good return on investment for NASA or any other space agency, scientifically speaking. New Horizons has unveiled so much about the dwarf planet that any follow-up would need to be significantly more advanced in order to be worthwhile, and this extra expense and complexity could be utilized much more effectively on another target. However, the lessons learned during this mission will help plan and design any future missions to the outer solar system, where countless other bodies are waiting to be investigated and share their secrets with us. Thank you for watching TurboMind. Don't forget to like, subscribe, and turn on notifications so you don't miss out on our upcoming videos.